they found abundant surrounding gas,
or space
they could grow quickly by feeding.
The universe.
This matters because we observe quasars very far away, which means we see them very early
just
in
a single
cosmic
moment
time,
frozen in the past.
and some host black holes
If this content
that are
interests
astonishingly
you,
massive.
please take a moment
That
to
raises
like the
a
video
puzzle.
and subscribe to the channel.
How did they grow
Your
so
support
big so
motivates
soon?
us to continue
One pathway
creating more
is rapid
meaningful
accretion,
videos.
where gas
It
spirals
is an
in and
unfolding
releases
story
enormous
that
energy.
is still written across
Another
the night
possibility
sky,
is frequent
carried
mergers
by
of
ancient
smaller
light
black holes
and echoed
in dense
the deep
early
structures
environments.
of the cosmos.
These ideas turn black
This
holes
is not just
into
an
characters
exploration
in
of
an
our
origin
origins,
story.
but of
They are
our
not only
connections.
endpoints of stars,
Also,
they may be
the atoms
architects
within
of
you
early galaxies,
share a lineage
influencing
with the
star
earliest
formation
moments
by
of the
heating and
universe.
stirring gas with
The
powerful
laws
radiation
that shaped
and
the
jets.
first galaxies
The earliest
also
black
shaped
holes
the world
could have
around
helped
you
shape
in
the
this
cosmic
very
neighborhood
moment.
they lived in.
As we explore
Some
this
models
vast
allow
beginning,
primordial
we
black
will move
holes
through
formed
mind-bending
before the
discoveries
first stars.
while revealing mysteries that are
There is
still
another,
beyond the reach
more
of science.
speculative route to black holes,
If you
and
enjoy
it begins
these
even
gentle
earlier
journeys,
than starlight.
I invite
if
you
the
to
infant
like,
universe
subscribe,
contained regions
or
that
share
were
a thought
slightly
below.
denser than average.
It helps others
Gravity
find their
could
way
in principle
here too.
crush some of
One
those regions
sleepy
into
soul
black
at a
holes
time.
directly, without any
For
star
now,
as an intermediate
there is
step.
nothing you need to do but
The
relax.
masses could vary widely
Allow your
depending
body
on
to
when they
soften,
formed.
and your breathing
Some would
to
evaporate
slow,
quickly through quantum
and
effects,
let the day fade
while
away.
others could survive to the
As we
present.
explore the origins
This
of the
idea
universe
is compelling
together.
because it connects early universe
Let's
physics
begin.
to a present-day mystery.
The Big Bang doesn't
It suggests
describe a
black
bang
holes
at all.
might carry information
It
from
describes our
conditions we
universe
cannot recreate,
expanding from an
and from
ultra-hot
times we
beginning.
cannot observe with
What
ordinary
gives
light.
this idea such force
It is also an idea
is that it
that
isn't a
invites
legend
testing.
or a hunch.
Primordial black
It is a
holes
model
would leave
that
signatures
ties together
through
many
gravitational
very
lensing
different clues
through their
into a
influence on
single,
structure or
consistent
through subtle
account.
effects on cosmic backgrounds.
When we look outward,
the models
we see that
are a
light
reminder
from
that
faraway
cosmology
galaxies
still
is
has room for
shifted
surprises,
toward longer wavelengths,
especially when it
and
comes
that
to what
shift
formed
increases
first.
the farther away
If
they
primordial
are.
black holes exist,
This pattern
they could
aligns
contribute
with a
to dark
universe
matter
that is
Dark
expanding.
matter is
When
known
we
by its
measure
gravity,
the faint
and
leftover
black holes
glow
are
filling the
gravity
sky,
in a concentrated
it
form.
matches what a universe
So
that was
it is
once
natural
much
to
hotter
ask
if
should
some
have left
fraction
behind
of the missing mass
could
when
be
we
black
examine the
holes
amounts
made
of
in
the
the
lightest
early
elements in
universe.
ancient gas. Those
challenge
values
is
line up
that the
with what a
idea
young,
must survive
hot
many
cosmos
constraints.
would have produced.
If too many
Taken
primordial
together,
black
these
holes
strands
had
of
certain
evidence
masses,
turn a daring
we would
origin
expect
story
more lensing
into
events
something that
of
can be
background
tested.
stars, or
The
we
Big
might
Bang
see
is
effects
not
on
merely
the
a
cosmic
starting
background.
point. It is a framework that
we might
continues to be
notice
checked against
disruptions
what
in
we
stellar
observe in the
systems.
sky. It was not an
Observations
explosion
have ruled out
happening
large
inside
ranges of
space.
possibilities.
It was
but
the expansion
not all
of
them.
space itself.
That leaves
In a
pockets
normal
of
explosion,
parameter
fragments
space
rush
where
outward into an
primordial
already
black holes
existing room.
would still play a role.
This beginning was stranger
Even
than
a
that.
partial contribution
The
would
room
be
itself
exciting
expanded.
because it would tie
That
dark matter
distinction
to
helps
an
explain
object
why
we
there is no
already
special
understand
center to
in general
indicate
relativity.
and no edge that one could travel toward.
It would also make dark
Every
matter
region
less
sees
like
other
an
distant
invisible
regions
particle,
moving away,
and
because
more
the
like a
distance between
population
them
of
is
hidden
being
compact
stretched.
objects.
This also explains why
Either
very
way,
remote
the search
galaxies
sharpens our
can
picture
recede
of
faster
what the
than the
universe
speed of
is
light
made of.
without
Cosmic
breaking
background
relativity.
anisotropies
Reveal
nothing
the universe
outrunning
is
light
very
through
close
space
to flat.
Instead, the
The
scale
modeled
of space
pattern
between
in the cosmic
faraway
background
places
is more than a pretty
changing.
map. It is a geometry
This idea
test.
also changes how we
In
picture
curved
the
space,
early universe.
light and distances
It
behave
was not
differently,
matter bursting
and that
from a
changes
single
how
spot.
large early patterns
It
appear
was
on the
an
sky.
everywhere that was
When
once
scientists
smaller,
measure the characteristic
hotter,
sizes
and
in the
denser.
background, they
Then
find they line up
expanded
with what
and
you would
cooled
expect
as a
if
whole.
space is extremely
The
close
universe
to
began
flat
as a
overall.
smooth fireball.
That does
Then
not mean the
grew
universe
lumpy.
is simple.
At
It means
first,
the
the
large-scale
cosmos was
geometry does
amazingly
not noticeably
even,
curve
with
like
energy
a sphere
and
or
particles
saddle
spread
within our
almost
measurement
uniformly.
precision.
If it had stayed
This is
perfectly
astonishing
smooth,
because slight curvature
nothing
could have
interesting
grown
would
important
ever
over
have
cosmic
formed.
time.
Gravity
Instead,
needs
the
tiny
universe
differences
seems
to
finally
amplify.
balanced.
The
This
remarkable
result also
twist
links to
is
early
that
expansion
the early
ideas,
universe
because
did
a
have
rapid
small
early
variations,
stretching would naturally
and we can
push
still
space
see
toward
their
flatness,
fingerprints.
like
They
pulling
were
wrinkles
slight,
out of fabric.
Yet they were
A subtle
enough.
sky pattern becomes a
Over
statement
immense
about the
time,
shape of
denser
reality.
regions
Flat
tucked a little
means
harder
geometry,
pulled in more
not
material,
that the universe is
and
small
became
or
denser
shallow.
still. That
When people
runaway
hear
process
flat,
built
they
structure
picture
from
a
almost
pancake
nothing.
universe. The
With
lumps
edges
became
you could
gas
fall
clouds.
off.
The clouds
In
became
cosmology,
the first
the
stars.
word is about geometry.
The stars gathered into
It
galaxies.
describes how parallel lines gathered into clusters.
How triangles add up.
When you look at the night
and
sky,
how light paths
you are
compare
seeing
with the
a
rules
grown-up
you learned in
version
school.
of faint, early
A flat
irregularities,
universe follows
magnified
the
by
familiar
gravity
geometry
into
of
a
universe
Euclid
on large
full
scales.
of shape.
Triangles
The
add up
oldest
to
light
about
we can
180
see still
degrees.
fills all directions
Light
today.
does not curve. This light
Because of
began its
global
journey when the
geometry
universe
alone.
finally cooled enough
That has
for
nothing to do
electrons
with
to
whether
settle
the
into
universe
atoms.
has an end or
Before
whether
that
it is
moment,
wide in
free
some
electrons
direction and
scattered
narrow
light
in another.
constantly. So the
Flat
cosmos
is
was
also
like a
not the
glowing
same as
fog
empty.
you could not see through.
A flat universe
Once
can still be
atoms
packed
formed,
with matter,
light could travel
radiation,
long
and
distances
mysterious
without being
components.
knocked around.
And all of them
Those
can influence
ancient
how
photons
expansion
have been
evolves.
crossing space ever since.
It is a
And they
reminder
still arrive
that
at
everyday
Earth from
words
every
can
direction.
mislead in science.
Time has stretched
Sometimes
their
the
wavelengths.
most important meaning
So
is
what
the one
began
you
as
cannot
hot,
picture
visible,
easily,
or
but
infrared
you can
light
measure.
now
Flat
reaches
space
us
can
mostly
still be
as
infinite,
microwaves.
depending
By studying
on
this
global
Paul
topology.
sky glow, scientists
Geometry
read a
tells you about
snapshot of the
local
universe
rules,
when it was
but
still young.
topology tells you about
It is
the
not a
overall
picture of
layout.
stars or galaxies.
A flat
It
surface
is a picture
can be
from
infinite,
before they
like
existed,
an endless plane,
and it lets us test
but it can
ideas
also
about
be
how
finite
the early
if
universe
space
behaved.
connects back on itself in
That
the right
afterglow
way.
is colder than deep space.
A classic analogy
Yet it is
a video
everywhere.
game world, where
Today,
walking
that
far
ancient
enough in
background
one
glow
direction
has cooled
brings
to
you
only a
back
few
to where you
degrees above
started.
absolute zero.
Locally, it can feel flat.
Empty space
Yet,
is often
globally,
described as cold.
it loops.
But this faint radiation
Some
sets a real
cosmological
temperature
models
floor
allow
that
a
permeates
universe
the
like
universe.
that in 3 dimensions.
It is not bright to
where
your eyes,
space is
yet
flat
sensitive
in its
instruments can
geometry,
measure it with
but
astonishing
still
precision.
wraps around.
It also
If
shows
that
up
were
in a
true,
surprising
They
place.
could be repeating patterns
A
in the
small part
sky,
of the static you
like
see
the
on
same
an
distant
untuned television
region appearing
is
in
the same
multiple
cosmic
directions
origin, arriving
at
after a
different
journey that
times.
began long before the Earth formed.
Searching for such patterns
The
is
afterglow
difficult,
is also incredibly
and nothing
uniform,
conclusive has
which is
been
a clue
found.
that the early universe
But the
was
idea
well mixed.
is
At the same
thrilling.
time, it contains
It shows
tiny
how the
variations
universe
could be
but
both
act like a
bounded
map of
and
primordial
edgeless.
conditions, with flatness
In that sense,
and
the
finiteness
coldness is not emptiness.
coexisting.
We
It
have
is
not measured
information.
whether the universe wraps
For a short
around
time,
itself.
the universe was hotter
It
than
is
any
possible
star core.
that space has
The
a kind
hottest
of
stellar
cosmic
corals
shortcut
reached tens
where
of
traveling
millions of
far
degrees.
enough in one direction
In the early
eventually
universe,
brings you
temperatures
home
were
from
vastly
another.
higher. At
If
such
that were
extremes,
the case,
atoms cannot
the
exist.
sky might contain
Even
subtle
nuclei
clues
cannot survive.
like matching circles.
Matter becomes a
repeating
sting
arrangements
arrangements,
in
fundamental
the background
particles
glow.
and radiation interacting constantly.
Created because light took
In that
different
environment,
routes through a
familiar
looping
distinctions
space.
blur. The challenge is energy
That the
turns
universe
into particle
is vast,
pairs, and
and
particle
we only
pairs
observe
turn back
a
into
finite
energy.
region.
The cosmos
If the
is not a
wraparound
collection of
scale
objects.
is larger
It
than
is a
what we
changing
can
state
see,
of physics
then
itself.
the evidence would be out of
As
reach.
expansion continued,
Even
the
if the
temperature
scale
fell,
is smaller,
and the menu of
the
possible
signal
particles
could be
changed
masked
with
by
it.
noise,
Some
foreground
species became
interference,
rare,
and the
others froze
complexity
out
of
and
how
remained.
light was scattered in the
This is
early
why
universe.
early conditions matter so much.
So this becomes
particle
a fascinating
physics of those
kind
moments
of absence.
help decide what
We can
ingredients
test
the later
certain
universes
possibilities would have available, rule some out, and
When we
leave
build
others
high-energy experiments on
It
Earth,
is a reminder
we
that
are not
cosmology
just
does
smashing
not only
particles.
ask what happened.
we are
it
briefly
also asks,
recreating echoes
what kind of
that
space
primordial
are we living
heat.
The
in the
answer
first
might be
minutes,
stranger than
the cosmos
distance alone
forged most
suggests.
of its helium.
The cosmic
Helium is
neutrino
often
background
associated
should
with
exist,
stars,
though
Yet
it
a
is
large
extremely
fraction
hard
of
to
it was
detect.
made before the first star
Neutrinos
ever
are
ignited.
almost ghost-like.
As the universe
Trillions
cools
pass
from
through
its
you
earliest
every
heat,
second,
photons
and
and
you do not feel a
neutrons began to stick together.
In the early universe, neutrinos
This was
were
a narrow
produced in
window.
huge numbers.
It was
And as
hot
space
enough for
expanded,
nuclear
they
reactions,
cooled into
yet
a relic
cooling
background.
quickly.
Similar
Within
in spirit
minutes,
to the cosmic
most free
microwave background.
neutrons
Were locked into
even more
helium
elusive.
nuclei, because helium
The difference
is especially
interaction.
stable.
Photons
That is why
scatter
about
easily,
a quarter
so
of
we
the
can
normal
catch them
matter
with
mass in the
antennas and
universe
detectors.
is helium today.
Neutrinos barely interact
Even
at
in
all.
places with few
So a
generations
true
of stars,
primordial
the
neutrino
same
background
early
is
process also
extraordinarily
created small
difficult
amounts
to
of
observe
deuterium
directly.
and a trace of lithium.
Yet its existence is
These
not just a
abundances
wish.
are not random.
It is a
They
robust
depend on the
prediction
density
of
of
early
ordinary
universe
matter
physics.
in the young universe.
Even if we cannot bottle
That
these
is why
relic
measuring
neutrinos,
light elements
their
in
effects
ancient
can still be be inferred.
can
They
test the Big
influence
Bang
how
story
quickly
with
the universe
impressive
expanded
accuracy during key eras.
Every atom in your
and they
body
slightly alter
traces
the growth
back
of
to
structure.
early
cosmic history.
In that way,
Some
an
of your
unseen
atoms
ocean
have a
can
lineage
still
that
leave
starts in the
tidal
first
marks
minute when hydrogen and
Detecting
helium
would be like
became
hearing
the
a
universe's
deeper layer
first
of the
longest
universe's
building
earliest
blocks.
chorus.
Many others arrived later.
The earliest
made
moments
inside
are
stars
described
that
by
lived,
particle physics
aged,
under
and
extreme
transformed.
conditions.
At the beginning, that anchors
the
your
universe
biology
was not a collection
formed
of
in stellar
galaxies.
furnaces.
It was a laboratory.
Oxygen
where
was built
energy,
in massive
fields,
stars
and particles
and scattered
constantly
when those stars
transformed into
died.
one another.
Iron,
The rules that
carries
matter
oxygen
most
in your
there
blood,
are the rules
was
of particle
forged in
physics.
violent
Because
stellar
temperatures
endings.
were so high,
Even
ordinary
rarer
matter
elements,
could not
like
exist
gold
in familiar
and
forms.
jewelry, are linked to
The ingredients
extraordinary
list of
events
reality
where
may
atomic
have been
nuclei
different,
are
with
blasted
particles
together
appearing
under
and
intense
disappearing
conditions.
as conditions changed.
None of these stories
This is why
replace the
cosmology
earlier one.
and particle physics
They layer
are
on top
intertwined.
of it.
When
The early
cosmologists
universe
ask
set the
what
stage
happened very
and
early,
provided the
they
raw
often end up
simplicity.
asking
Later
what particles
cosmic
existed,
generations
how they
added
interacted,
complexity.
and what symmetries held.
When you hear that you are made of
physicists
star stuff,
test high-energy
true.
theories,
And it
they
is
often
also
ask
only the
what
middle
those theories
chapters
would have
of a
done
longer
to the
origin.
infant universe.
Tiny early
It is a
ripples
partnership
grew
into
across
galaxies,
scales, clusters, and
The largest
cosmic
object
webs.
we can study becomes
Those early
evidence
variations
about
were
the
not
smallest
just
laws,
random bumps,
and the smallest
they had
laws
patterns
become
that
a
modern
story
surveys
about the
can
whole
still
sky.
detect.
The Big Bang
Ordinary
model
matter
does
alone
not yet
would
explain
have
why
struggled
constants
to clump
have their
quickly
values.
enough, because
The
radiation
model
pressure
describes how the
resisted
universe
collapse
evolves
in the early
given
era.
certain rules,
An
but it does
invisible
not fully
component
explain
that
why the
interacts
rules
mainly
are
through
set the way
gravity
they are.
provided extra
Why does
pull
gravity have
and
its
helped
particular
structure form
strength?
earlier and faster.
Why do particle masses take the
Over
values
time,
they do?
matter streamed into
Why does
denser
the vacuum
regions,
behave
and
as it
vast
does?
filaments grew between
These
enormous
numbers
voids.
shape everything.
Galaxies formed
Small
along these
changes
filaments
could prevent
like
stable
beads
atoms,
on threads,
alter stellar
and clusters
lifetimes,
assembled where threads
or erase the
intersected.
chemistry that makes complex
This large-scale
structures
structure
possible.
is one of the most striking
Scientists
outcomes
explore
of
many
simple
ideas
gravity
here.
acting for a
Some
long
search
time
for deeper,
on small
unifying
beginnings.
theories that would make the constants inevitable.
It also
Others
functions
consider
as a
whether our
vast
observed
laboratory
values could
by
be
charting
selected from
where
a wider
galaxies
landscape
lie
of possibilities,
and how their arrangement changes
This question
with
is
distance.
fascinating.
Researchers
Researchers can
can
test
test edge
how
of what
rapidly
science
the universe
currently
expanded,
test.
and how strongly
It is not a weakness
gravity
of cosmology
guided its
It is a
development
frontier
over cosmic time.
The Big Bang story tells us
Our
how the
very
universe grew up.
existence relies
The
on a
constant
slight
question
imbalance between
asks
matter
why
and
this
antimatter.
universe had this particular
In the hot,
personality in the
early
first
universe,
place.
energy
It also
produced
does not
matter,
explain
and
why there is more
antimatter
matter
in
than
paired
antimatter.
form. And those
The
pairs
laws of physics
could annihilate
often treat
back
matter
into
and
light.
antimatter as
If the
mirror
cosmos
partners.
had created perfectly
In the early
equal
universe,
amounts,
they were created
nearly
together in
everything
abundance.
would have wiped
And
itself
they
out.
could annihilate back
leaving
into
behind
radiation.
a thin sea
If
of
the balance
radiation
had been perfect,
and
you would not
almost
have
nothing
stars,
more.
planets, or air.
Instead,
You would have
for
mostly
reasons still
light.
under study,
There
yet
was
the
a
universe
minute clearly ended up
surplus
with
of
a
matter.
leftover supply of matter.
After most
That
annihilations
leftover
were complete,
is everything solid
that
you have
small
ever
remainder
touched.
became the substance
The mystery
of
is not
stars,
whether it happened.
planets.
The
and
mystery
people.
is how the process
This
must have
stands
occurred
as one
under
of the
conditions
deepest,
that allow
unresolved
tiny
questions in
asymmetries
cosmology
to become permanent.
because it connects the
and
largest
it must
scales of
involve
the
physical
universe
effects
to
that
particle
slightly favor
physics.
matter.
The universe
over
requires
antimatter.
processes that treat
This is
matter
one of the most
and
thrilling
antimatter
open problems,
just slightly differently,
because it ties existence
and it
itself
requires
to
conditions
subtle microscopic
where that
behavior.
difference can have real
It
consequences.
also shows how cosmic history
Experiments
depends on
study
tiny
subtle
differences.
symmetry violations.
A small
While
imbalance
cosmologists
early on
look for clues
becomes
in the
a
sky.
universe with structure
The fact
later.
that anything solid
Solving
exists
this
at
would
all
connect the
is
first
evidence
moments
that
to
the
the
fact
early universe
that anything
played
remains
favorites
just
at
a
all.
little. Timekeeping for the
Baryogenesis
universe
is the name
uses
for
age
processes
measured
that
by
could
cosmic
create that
expansion.
imbalance.
Instead of
This
counting
is the umbrella
birthdays,
term for the
cosmologists
universe's method,
read the universe
whatever it
like
was,
a clock
for
built
tipping
into
the
space
scales
itself.
toward matter.
They measure
Any
how
successful
fast
mechanism
galaxies
must
must
meet
meet
different
different distances,
requirements,
and how that rate
It
has
must
changed
allow
over
matter
time.
number to change.
Expansion
treat
leaves
matter and
multiple
antimatter
records.
differently.
It stretches
must
light from
occur
distant
out of
galaxies,
equilibrium,
and it
so the
also
universe
sets the
cannot
size of
simply
patterns
reverse it.
imprinted in
Those
the early
conditions
universe
are demanding.
that we can still measure
And they
today.
make baryogenesis
And those
powerful
independent
filter
measure
from
theories
degree.
beyond the
They
standard
pin down
model
a
of particle
consistent
physics
timeline for cosmic history.
Different
That
ideas
is how we
place
can
the
say
action
the
at different
universe has
times.
an age at all.
Some connected
Even
to very
though
early
nobody
phase
was there
changes,
to watch it
others
begin.
to neutrino physics,
This
and others
approach
to
is
physics
also
at
why
energies
debates
far
about
higher
the
than we can
exact
reach in
expansion
accelerators
rate matter so much.
What makes this so
A
compelling
small change is the investigative nature of the hunt.
the inferred past.
The crime scene
and
is
it
the
can
entire
hint that
cosmos,
something
and the
important
clues
is
include
missing
tiny
from
symmetry
our current
violations
picture.
measured in laboratories
The
along
early
with the
universe
basic
was
fact
so
that
dense
galaxies are
that
here at
light
all.
could not travel freely.
Each improvement in measurement
Imagine
tightens the
trying
list
to
of
see
suspects.
through a storm, where
The aim
every
is not a
beam
clever
is
narrative.
instantly scattered.
It is a mechanism that obeys
In the
nature's
earliest
rules
eras,
and matches the
space
universe
was
we
filled
see.
with charged particles.
Early phase
moving
transitions
fast,
may have altered
and
the universe's
photons
forces.
kept colliding with them.
As the cosmos cooled,
Light
likely
existed,
crossed threshold
but it could
moments
not
where the
carry an
behavior of
image
fields
across any
shifted
meaningful
and new
distance.
distinctions appeared.
In
The
everyday
whole
experience,
universe acted like an
water
opaque,
freezing
glowing fog.
is a familiar example of a
This is a
phase
crucial
transition.
detail because it means
In the
our
early
cosmic
universe,
story
such
has a natural
transitions could have
visibility
involved
limit.
the forces themselves.
We cannot see
changing
earlier
how
than
particles
the moment
interact
when conditions
and how
changed,
properties like
and
mass
light finally
emerge.
started moving in
These
long,
events
straight
may have
paths.
released latent energy,
Before that,
created
the
exotic
universe
defects,
was not
or
dark.
generated
It was
new
too
populations
bright,
of particles.
too hot, and too
They might
crowded
also
for
have affected
transparency.
baryon genesis,
That
if
early
conditions
opacity
allowed matter
also
to gain
shaped
a slight
what could
edge.
form.
The
With
idea
radiation
is
tightly
dramatic
coupled to
because
matter,
it suggests the
pressure
universe
fought
was not
gravity,
only cooling,
and growth was forced
it was
to wait
reorganizing
for the
its
universe
fundamental
to cool
rules
and thin.
as it cooled.
When atoms
This is
first
also
formed,
why
the
cosmologists
universe
care
suddenly
about
became
symmetry.
transparent.
Symmetry can be
There was a
present
time
at high
when
energy,
the cosmos
then
changed
break
character,
as the universe expands,
almost like a curtain
leaving
lifting.
behind new physics in a lower
As
energy
temperatures
world.
dropped, electrons could finally
If we
stay
could
bound
map
to
these
nuclei
transitions more clearly,
instead of being torn
we
away
would be
by
reading
energetic
the timeline
collisions
of the universe,
Once
learning
most
what
matter
kind
became
of universe
neutral,
it would become.
photons stopped bouncing
The
constantly
electroic era
and began to
shaped
stream
how
through
particles
space.
gained mass through symmetry.
That transition
breaking. Very
released
early
the
on,
oldest light
the
we can
universe
observe.
was so hot that
It
forces
also
we
set
now
the
treat
universe
as
on a new
separate
path,
behaved as
because
one.
neutral gas
combined
behaves differently from an
electroequal force.
ionized plasma.
As expansion cooled everything,
Pressure dropped,
a field that filled
cooling
space
became more
settled
effective,
into a new state.
and gravity had a clearer
And that
run
shift
at gathering
changed
matter
how
into
certain
denser
particles
regions.
moved through it.
This is one of those moments
Some
where a change in
particles began to
microscopic
experience
behavior
resistance
rewrote
that
the
shows
fate of
up to us
everything
as
on the
mass.
largest scales.
Photons
It is also
stayed
why the
massless,
early universe
which
can
is
be
why
studied
light can
like a
travel
fossil.
freely across the
A
cosmos.
single transition left a whole
Other
sky of
particles
information,
gained mass,
and we can still
which
map
helped
it
shape
with precision.
what could exist later.
Hydrogen formed
From
first,
stable atoms
then helium,
to longevous
then a whisper
stars.
of lithium.
This is one of
That
the
simple
strangest
chemical
ideas
starting
in
point
physics,
shaped the
because it
universe's
means
personality
mass
for a
is
long
not only a
time.
property of an object,
With almost no
it is
heavier elements
also
available,
a relationship
early gas
between an
could not
object
cool easily,
and the state of
and
space
cooling matters
itself.
because it helps clouds collapse to
The
form
early
stars.
universe did not just
Hydrogen
make
and
matter.
helium have limited
also
ways
set
to
the
shed
rules
energy
that matter
so
must
the
live
first
by.
star-forming regions likely had to be
Quark,
massive,
gluon, plasma
patient, and
once
extreme.
filled the cosmos before
Lithium
protons
existed
could
in
form.
tiny amounts, but it was
Before
far
there
too
were
rare
protons,
to change the
the
chemistry in a
universe
big way.
was too hot for quarks
This is why
to
the
stay
first
confined
generations
inside
of cosmic
quarks
objects
and
were probably
gluons
very
moved
different
in a
from
dense
familiar stars
energetic
today.
mixture.
Later on,
Where the usual
once
boundaries
stellar
of
processes
particles
began
were not
enriching
yet locked into
space with
place.
heavier elements.
Then cooling
pushed the
became more
universe
efficient
through a
and
transformation.
smaller stars could form.
Quarks became
In a
bound
sense,
into head,
the early universe
including
began
protons
with a
and
very
neutrons.
limited toolkit,
and the cosmos
and the
gained
complexity
familiar
we see
building
now
blocks
was
of
earned
later chemistry
slowly
through cosmic time.
This transition
and
is
repeated
sometimes
cycles of
compared
birth
to
and
steam
destruction.
condensing into liquid.
The first atomic
Not because
nuclei
it is the
formed
same process,
before any stars
but because
ever
the whole
existed.
character of the material
It is
changed
strange to realize
temperature
that
fell.
nuclear physics happened
It is a
on a
wild
universe-wide
thought that
scale
every proton in
before
your
the
body
first pinprick
traces
of
back to a
starlight.
time when protons
In those
could
earliest
not
minutes,
exist.
the entire
The
cosmos
universe had to
was
pass
hot
a
enough for
thermal
nuclear
threshold
reactions,
before it
and
could
it was
even
also
form the
expanding
particles
fast
that
enough
would later
to shut
form
them down.
atoms.
That
Our
combination
solid world
matters.
depends on that
Stars
ancient
can keep
shift
fusing for
from
millions
free
or
quarks
billions
to
of
confined
years
matter.
because gravity holds their
Particle
cores
colliders
hot and
recreate
dense.
tiny echoes of early
The young
universe
universe
conditions.
had no such confinement.
On Earth,
it
we
cooled
cannot
as
rewind
it
the
expanded,
cosmos,
and it moved
but we can
past
imitate
the conditions
a few of its
needed
early
for fusion.
ingredients.
So the
for a
first
fraction
nuclei
of a second.
were created in a
heavy
brief
ion
global
collisions,
burst of nuclear
nuclei
assembly.
are smashed together
And then
at enormous
the
energies.
opportunity vanished,
And the impact can briefly produce a
This
state of
early
matter
chapter set the
closer to
baseline
early
composition
universe
of the universe,
than to
and it
everyday
established the
solids
raw
and
material
gases.
from which later stars would
Detectors
build everything
then
else.
watch what sprays out.
It is an origin
those
story
particle
written
patterns
in
act
physics
like
rather than
clues
flames.
to what the hot phase was
Neutrinos
like.
flooded the universe
Researchers
long
look for
before the
signs of
first
collective
atoms
form.
flowed.
energy loss.
Neutrinos
and
are
other
real
behaviors
particles
that suggest
and they interact
matter is
so
acting
weakly
as
that
they
they
can
can
pass
pass
through a
through
planet
with
with hardly a whisper of
rather
contact.
than a simple gas of particles.
In the early universe,
It is
they were
remarkable
produced
that
in
a machine
enormous numbers,
built on a planet
and then they
can
slipped
probe
away from the
conditions
rest of
that
matter
once filled
when the cosmos
entire
was still
universe.
extremely young. Colliders turn
If a
cosmology
background sea
into
of
an
these
experimental
ancient
science
neutrinos
in
still
miniature.
fill
Space today. They cannot
It would be a
reproduce
relic
the whole
even
early
older than the
universe.
earliest light
But they can
we can
test
see.
pieces of its physics. Detecting it
And
directly
pieces can
is
still
brutally
change the
difficult
story.
because neutrinos
The
rarely
cosmic
interact
background
with anything.
is not
light from the first stars. Their presence matters. This common mix-up is
They affect
understandable
how
because
quickly the
both
universe
involve
expanded
very
in its
old
earliest
light.
moments.
The cosmic
And they leave
background
subtle
comes from a
fingerprints
time on the
before
growth of
any
structure
stars
over
existed.
time.
It was released when the
In a way,
universe was
the
still
universe
a hot,
has been filled
nearly
with invisible
uniform sea
travelers
of matter
since the
and
beginning,
radiation.
carrying information
Long
from
before
eras we
galaxies
cannot
had
observe
assembled
with light.
Starlight, by contrast,
Most matter
is
today
produced
is not
inside
atoms.
stars.
It is invisible,
and carries
dark
fingerprints of stellar atmospheres.
When astronomers weigh
like
galaxies
sharp
by how
spectral
fast
lines
their stars
and
orbit,
distinctive colors.
the numbers do not match what we can see.
The cosmic background
Something unseen
is different.
adds extra gravity.
It is an all-sky
The
glow
same mystery appears
with a
in
near
galaxy
perfect
clusters,
thermal
where
spectrum,
visible matter is
and
not
it
enough
does
to
not
hold the
point
system
back
together.
to individual sources.
It also appears
It
when
points
mass
back to a
bends
time
light
when
from
the
background
universe
galaxies,
itself was
which
the
lets us
source.
map gravity directly without
Keeping this
relying on
distinction
starlight
clear
at all.
matters, because it
Again
changes
and
what
again,
the signal
the
can
maps
tell us.
show more mass than the atoms
Starlight
can provide.
teaches us about
Dark
astrophysics
matter
and
is the name we
chemical
give
history.
to that missing
The
gravitational
background
ingredient.
teaches us about
It does
the
not
early
seem to
conditions
shine, and
that
it does
set
not
the
seem to
stage
absorb
for
light in the
everything that
usual
came
way.
later.
Yet it shapes the
It is
universe
older.
on enormous
It comes
scales.
from when the universe first
One of the most
appeared.
exciting possibilities in modern
There was a
science
moment
is
when
that
the
dark
universe
matter
stopped
could be a new
acting
kind of
like a
particle,
fog and
and
started
discovering it
acting
would expand
like
physics
transparent
beyond the
space.
familiar catalog. Dark matter
Before
shaped
then,
the first
light
structures
could not
by
travel
pulling gas
far
into
without
wells.
being scattered.
Long
So the
before there were
cosmos
shining
was
galaxies, dark
but
matter
visually
began to
trapped.
gather into clumps under gravity.
When conditions changed,
Those clumps formed a
photons
scaffold
finally
that ordinary
streamed
gas could
freely.
fall into.
and they have been
Gas
traveling
alone would have had
ever
a harder
since.
time settling early on
What
because
we observe
radiation
today
pressure
is
pushed
sometimes
back.
called the
Dark matter did
surface
not
of
feel that
last
pressure,
scattering.
so it could start building structure
Not because
earlier.
it is a physical
Over
law,
time, gas
but because
collected
it
inside
marks
these
the last
invisible
time
halos.
those
cooled where it
photons
could,
were
and
repeatedly
eventually
bounced
ignited
around.
the first stars.
It is also
In
a
this picture,
strange
the
kind
first
of
galaxies
time
were born
machine.
inside gravitational
No matter
wells
where
that
you
were
look,
already there.
you are seeing a
And
shell
the bright
of
parts
that
we see
same
today
era
are like
at
lanterns
different
hanging
points
inside
in
much
space.
larger, dark structures.
Even nearby
Computer
directions
simulations
in the sky
show this process in
correspond to
vivid
regions
detail.
that were far apart.
They grow a
back then,
cosmic web from tiny
which is why
beginnings,
the subtle
and
pattern
they produce
across the
filamentary
shell
networks
is so
that look
informative.
remarkably like what surveys of
The
real
universe
galaxies
cleared
reveal.
once, and
It is a
behind
powerful
a
example
sky
of how the
filled with
unseen can
evidence.
leave visible architecture.
The afterglow has been
Dark
stretched
energy
from
makes
visible
cosmic
light
expansion
into
speed up,
microwaves.
not slow down.
As the universe
For a long time,
expands,
many people
it
expected
stretches
gravity to
wavelengths
gradually
in
slow
transit,
the expansion,
like a
ball
tune
tossed
lowered
upward.
as the instrument grows.
Then, observations of distant
cosmic
exploding
background
stars
began
suggested
much
the
hotter
opposite.
than it is now.
The expansion
and
has been
hotter
acceleration
radiating
for the
peaks
last
at
several
shorter
billion
wavelengths.
years.
Over billions
Dark
of years,
energy is the name given to
expansion
whatever is
lengthened
driving
those
that acceleration.
wavelengths until they moved
It might be
into
a
the
constant
microwave
energy
band.
of space itself, or it
This
might be something that
stretching
evolves
also
over time.
cools the radiation
Either way,
in a predictable
it changes
way,
the universe's
because
long-term
longer
future.
wavelength light carries
If
less
acceleration
energy
continues,
per photon.
distant galaxies will
That is
slip
why the
beyond a
background
cosmic
temperature
horizon
today
and become
is only a
unreachable.
few degrees above
Even
absolute
in principle,
zero.
that does not mean the
It is
universe
not because
ends.
the universe
It means
cooled, like
the
a room
visible
losing heat
universe
into outside
becomes
space.
smaller from our
It
perspective
cooled
as time
because
goes
space
on.
itself expanded.
This discovery
and
also
that
connects
expansion
the
diluted
very large
energy with
and
the very
stretched
small.
light. Because
The result is a
simplest
signal that is
explanation
both
involves
ancient
vacuum
and current,
energy.
arriving right
And
now
vacuum
as
energy
microwaves
is tied
from
to
every
quantum
direction.
ideas
that are still being
With
wrestled
the right
into a
instruments,
complete
we can
common
measure that
theory.
ancient heat long after it faded from visible
Galaxies
brightness.
are racing apart.
As
Because
space expands,
between them
it also
keeps
stretches
stretching.
wavelengths,
creating cosmic
Expansion
redshift.
shows up as a relationship
Redshift
between
is
distance
the universe's
and speed,
built-in stamp
and
on
it makes
traveling
the
light.
cosmos feel alive.
When a
with
galaxy
motion.
emits light,
That
that
light
light begins
begins
its
its
journey
journey
with a certain
wavelength.
While it travels,
As the
scale
scale
of the
space
universe
can
increases,
increase,
and the
light
wave is
traveling
stretched
through
along with
space
it, gets
By the
stretched
time it
too,
arrives, its
and its
wavelength
color
is
shifts
longer,
toward
and its
the
color
red.
has shifted toward the red
That is
end
why
of the spectrum.
redshift is such a
This
central
is not
tool
only an
in
effect of
cosmology.
motion through space,
It
It
is
is an
not
effect
only a
of the
sign
changing
that
geometry
things
of
are far
space
away.
during the journey.
It is also
That is
a
why
sign
redshift
that the
is so
universe
central to
changed
cosmology.
while the light was in transit.
It links what we measure in a spectrum
Yet
to the
this
history of
stretching
expansion
has limits
between
in
then
everyday
and
life.
now.
Your body does not
It also
expand
gives
and your
every
solar
photon
system
a
does not
story.
swell, because
The light
gravity
left a
and other
different
forces
universe
hold
than
bound
the one it
structures
arrived
together.
and the stretching of its wavelength
Expansion is most
the
obvious
trace of
across
that
the
change.
immense spaces between
In a
galaxy
sense,
groups,
the universe
where
signs
nothing
its
strong
name
enough
on
resists
every
the
distant
widening
being.
of distance.
Redshift is how we
Thinking
tell
this
this
way
way
can
galaxies
reframe
are
the
seen in
night
the
sky.
past.
It is
When
not a
astronomers
fixed
spread a
dome of
galaxy's
light.
light into a spectrum,
It is a
they look
record
for
of changing
recognizable
geometry.
features like patterns from hydrogen
We see distant
or other
galaxies
common
as they
elements.
were, not as they
Those
are now.
features appear shifted compared
When a
with
telescope
laboratory
catches the
measurements.
light
The
of a
amount of
faraway
shift
galaxy gives the
It is
galaxy's
catching a
redshift.
message that has been traveling
And
for a
redshift
very
can
long
be translated into how
That
long
means
the light
the
has been
image is
traveling.
history, not
Once
a
you
live
adopt
view.
the cosmological model,
Some
that
of the
gives a
faint
look back
smudges
in
in
time.
deep space photographs
It is
are
one of the
galaxies
few
from an
ways we
era
can
when the
place
universe
distant
was still
objects
young,
on a timeline
when stars were
without
forming
knowing
fast
their
and
full
shapes were
histories.
rougher and more chaotic.
With redshift, a deep
This
survey
is why
becomes a
astronomy
kind of
is so different
layered
from most
museum.
sciences. You
Nearby
cannot bring a
galaxies
galaxy into a
represent
lab,
later chapters.
so the
while
universe brings you its past instead. It also means the sky is layered like a timeline.
Nearby galaxies show later chapters, and the most distant ones show earlier chapters. With newer instruments, we are pushing that time window farther back. And each stage shows how the familiar universe we see today came to feel like home. The observable universe has a horizon because light has had limited time to travel. There is a limit to what we are able to observe, and it exists for a straightforward reason. The universe has a finite age. As a result, light has only had a finite amount of time to reach us from beyond a certain distance. Even if something exists out there, its light simply has not arrived yet. This produces a natural cosmic horizon. It is not a physical wall in space, and it is not the edge of the entire universe. It is an edge of information for us. The size of this observable region depends on how expansion played out over time, because expansion determines how far light can move while space itself is stretching. This is why cosmology feels like detective work, governed by strict rules. The universe provides us with a sphere of evidence, and within that sphere, we must rebuild the story using light, gravity, and the faintest patterns that survived from earlier epochs. Some regions will never be observed, because expansion carries them away faster than their light can reach us. Even if you wait forever, there are places whose signals will never reach us. This is not because they are hidden behind dust or blocked by something in the way. It is because